Okay, so this is a video on compound interest. At any point, you obviously can pause it, so then that way you can write down what you need to, or you can speed it up if I'm going too slow. So compound interest is in this unit of exponential functions because compound interest is actually using an exponential function. But we also are going to look at simple interest, which is not using an exponential function, but it's using a linear instead. So we'll start with simple interest. So simple interest is interest that grows linearly. So the idea is that you are taking notes as you follow along. So interest that goes linearly, meaning that we're adding or I should not say subtracting. We are adding the same amount each time. So the formula, we're using T of n just kind of like how we did for our sequences. So the formula is T of n equals P. So P is representing the principal. So principal means the initial amount invested. So that's your starting amount. So it's going to be your principal, and then plus it's your principal times the rate. And that will kind of make more sense once we look at an example. But basically, if you have simple interest at a certain rate, you would take that percentage and multiply that by your principal to see what the actual numerical value is that you're adding each time. So P times R and then N. And N represents the time in years, or the number of years. Okay, so we're going to look at an example of simple interest. So we have Ingrid invests $2,500 into an account that earns 3% simple interest compounded annually. So we want to first create an equation. So I know that this is simple interest because it says the word simple interest. So we are going to have T of n equals my principal, which is the initial amount invested, which is $2,500. And then plus, I need to figure out what amount I am adding each year, which is 3% of $2,500. So it's P times R. So my principal is $2,500 times R, which is 0.03. And then that's all multiplied by the number of years. So the final equation is T of n equals 2,500 and then plus 2,500 times 0.03, which is 75n. So what that means is every single year you're earning $75 in interest. So how much money will be in the account after 5 years? So what we would do is T of 5. So T of 5 equals 2,500 plus 75 times 5, because each year you're earning $75. So this would be 2,500 plus 75 times 5. 75 times 5 is 375. So this would be 2,875. So after 5 years, you would earn 2,800 or I shouldn't say you would earn, but there would be $2,875 in the account. The money that you would actually profit is $375. Okay, so that is simple interest. So now for the rest, we are going to be looking at compound interest. So compound interest is all exponential functions, but we are going to be looking at compound interest annually and then also compound interest more than once a year. So first we'll look at compound interest annually. So the function for this is T of n equals P plus, then it's going to be 1 plus R to the n power. So P is still standing for principal, which is the initial amount invested. R is still representing your interest rate. And N is time in years. And then I'm just going to kind of make a note here that this is an exponential function. And we can see that because it looks like it's the form of an exponential function. All right, so we have Barnaby, and he has invested $3,500 into an account that earns 4.3% interest compounded annually. So the keywords are compounded annually. It doesn't say anything about simple interest, so that gives it away that we're just using compound interest. So the equation would be T of N equals, and then our initial amount invested, which is $3,500. Then it would be 1 plus, so our rate we need to turn into a decimal, so it'd be 0.043, and then to the n power. So then our final equation, we would just kind of clean this up by combining like terms. So it'd be 3,500, 1.043 to the n power. So it says how much money will be in the account after 6 years. So what we're really doing is just evaluating the function at 6. So T of 6 equals 3,500, then 1.043 to the 6th power. Now in certain calculators, depending on the model and the how new it is, you might want to do 1.043 to the 6th power first and then multiply by 3,500 just to assure that it's following PEMDAS. But T of 6, once you do that, will be 4,505 and then 0.82. So I'm rounding to the nearest hundredth because we're talking about dollars, so it just kind of makes sense. And then obviously you should notice that the amount goes up. If you're not getting a higher amount, then we didn't do it right because we're gaining interest, so we're gaining value. All right. So our last one is compound interest, that it's compounded more than once per year. So it would say something like it's compounded monthly, daily, quarterly, weekly, semi-annually, and we'll kind of talk about that as we look at this example. So the formula for this is very similar to the one that we just looked at. So it's P, then it's 1 plus, but instead of just R, it's going to be R over T, and then this is all to the NT power, and I'm going to kind of fix this. Okay, so now we have another variable, which is T. So T is going to be how many times per year that it's compounded, and it will clearly tell you. And then again, we know that N is equal to like time in years. Okay, so we have Svetlana invested $8,000 into an account that earns 3%. I should have said interest, compounded quarterly. So quarterly is the key word. So we are going to go ahead and write an equation for this. So we know it's T of N equals. We know that our principal amount is $8,000 because that was the initial amount invested. I know it always is 1 plus. Now, because it says compounded quarterly, you want to think of how many times per year. So quarterly would be 4. If it said semi-annually, it would be 2. If it said daily, it would be 365. Monthly, it would be 12. So it's just how many times per year. So we know that the rate would be 0.03. And then I'm going to divide that by 4. And then it would be to the NT power. Well, we don't know N, but we know T. So I'm going to put 4N. So to clean this up, it would be T of N equals, so I would do 0.03 divided by 4 on my calculator, and then I would add the 1. So it's 8,000 times 1.0075 for n. So when it says how much money will be in the account after 8 years, then we are evaluating that function at 8. So it's t of 8 equals 8,000 times 1.0075, and then it's to the 4 times 8 power, which is really to the 32nd power. So you would do 1.0075 to the 32nd power, and then multiply that by 8,000, and we get 10,160.89. So really, in terms of the context, that means in the account there would be $10,160.89. So they earned $2,160.89 in that amount of time. So definitely feel free to rewatch this, and then the notes are posted as well if you just want to look at that.